Okay, so this is what we get. VO plus AT 1 plus 1 over 1 plus 1, T0 which is 0, and T. And we all know why we've applied 1 plus 1 and 1 plus 1 down here, but it was not applicable to this one here. The main reason is the VO was a constant, but here this is not a constant. Since this T is changing and we are integrating this T with respect to a T, that's why I had to apply this principle which is here. So now from here, what you're going to get is the upper limit minus lower limit. So you get x minus xo is equals to, you also apply the same upper limit minus lower limit. So when you replace in the T where there is a T here, you get VO T plus AT squared divided by 2. And then minus, if you replace in the zeros where there is a T, so you get minus 0. So I won't include that. Then from here we can now just make x a subject to a formula. So I mean your x is given by xo plus VOT plus 1 over 2 AT squared. Then you're done using your calculus. Okay, so we can now move on to a third equation of motion, which is V squared is equals to VO squared plus 2A change in x. So let's also use algebra and calculus to come up with that equation. So we'll start with algebra. So let's do algebra, then we'll move on to calculus. So when you're using algebra, we can now use the same equation, which was change in x is equals to the average velocity multiplied by the time. So from this equation, we all know that where the v, the average velocity, is the final plus the initial divided by t2, and then where the t will be given by, from the first equation of motion, if you remember this equation here, if you make t a subject to a formula from this equation, what you're going to get is v minus v over a. So you're saying from this equation, make t a subject to a formula, and it's the one that we're going to be using for this one. So if you make t a subject to a formula, this is what you're going to get, v minus vo divided by a. Now that we have all this, we can now just replace it to come up with the equation that we've been asked to come up with. So you have your change in x is equals to, where there is the average velocity, you say v plus vo divided by 2 multiplied by the t, which is v minus vo over a. So therefore our change in x will be given by, you can now multiply. So the v times the v, you get v squared. The v times the vo, you get negative vo. The vo times the v, you get plus vo minus vo squared. Then divided by what's down here, 2 times a, you get 2a. So therefore your change in x is equals to, this and this are going to cancel out. So you have v squared minus vo squared divided by 2a. So you can now cross multiply to make v squared the subject of formula. So you get v squared minus vo squared is equals to 2a, the change in x. So if you make v a subject of formula, you're going to take this on the other side. So you get v squared is equals to vo squared plus 2a, and then where there is change in x, it's x minus xo. So that's how you come up with that equation using your algebra. So using you can also use calculus for the same equation. So if you are using calculus, we can also use a is equals to dv over dt. This is the equation that we are using. Now, for us to use this equation, and let's compare with the equation that we have. There is displacement in the equation. But in this one here, we don't have the displacement. But I know that the displacement is hiding in the velocity. So we need the way of introducing the velocity or the displacement without changing the meaning. So what I can do is I can say a is simply equals to, I want to introduce the dx. So I can say, okay, let me separate these two. This would be over dt multiplied by dv over something. I haven't changed the meaning, and then I'll introduce dx down here, also dx down there. So that the dx and the dx are able to cancel out, and I'll remain with dv over dt. So what I've done is I've just introduced the dx without changing the meaning. The dx is up and down at the same time. So what are you going to get now? We all know that dx over dt is simply velocity. So what you're going to get is a is equals to whatever is here is velocity multiplied by dv over dx. Okay? Then from here we can now cross multiply. So you get v dv is equals to a d dx. So to get rid of the dv, you introduce the integral on both sides. So here we are focusing on integrating whatever is before the dv, and here whatever is before the dx. So whatever is before the dv here is v. So if you integrate the v with respect to the v, what you're going to get is v squared divided by 2. If you remember that principle that we used in the previous example. So you have v squared over 2, and then the limits are the initial velocity to the final velocity, which is equals to, even this side, if you integrate with respect to x, so the a with respect to x are going to get ax, and this will be from the initial all the way up to the final. Okay, so if you do upper limit minus lower limits, you get v squared over 2 minus v all squared over 2 is equals to ax minus ax 0. So now what you're going to get is v squared over 2 minus v all squared over 2 is equals to, if you factorize the a, you get a x minus xo. So you can multiply